So in this last video for bond price volatility, we're going to take a look at approximating duration and convexity. We got a couple of simple formulas, really simple in practice to use, much easier than calculating duration and convexity with some exactness. So first let's look at this approximating duration formula. We've got a P minus less a P plus, and the minus there indicates that interest rates are lower. The price when interest rates are lower. We're going to subtract from that the price when interest rates go higher, and we're going to divide that by 2 times PO times the change in Y. So PO is the initial price. So you've got all that information here. For convexity, we're going to use the same symbols, same meanings involved, but we're going to get a slightly different formula here. P when interest rates are higher plus the price when interest rates are lower, take away 2 times the initial price, and divide all of that by the initial price times the change in interest rates squared. So let's go to Excel and take a look at that in practice. So for example here, I've got the bond A. We've been dealing with this bond all along the way. We calculated the duration way back when at 4.72. And so what I've got here is the initial setup. The price is $1,023.81, and that's based on the initial yield to maturity of 7.5%, a coupon rate of 8%, etc. If we increase rates by 10 basis points, so that would be the P plus, we've got a new price that's going to be $1,018.99. So I'm just using the price function in Excel. I've changed the interest rates by going up 10 basis points. You can see that there. And I've got a new price of $1,018. To get P minus, the P when interest rates go down, I change the interest rate to 7.4. That is, I'm taking it down 10 basis points. I calculate the new price, and I've got $1,028.65. So that's the P when interest rates go down, the price when interest rates go down. If I plug that into the formula for approximating duration, I'm going to take the P minus, subtract from that the P plus, and so I've got that here, and then in the denominator I'm going to take 2 times the initial price times the change in interest rates. So when I plug all that stuff in, I would get an approximation of duration of 4.7186, and if we rounded that to 2 decimal places, I would get 4.72. I want to show you how close that is. If I calculate the modified duration using the function in Excel, I would get 4.7186 if we rounded it to 4 decimal places, 4.72 which is at 2 decimal places, which is exactly what we've had all along. So our approximation of duration is very close indeed. Same thing with convexity. If we plug the formula in and put all the pieces and parts where they belong, use the formula that we had here in the PowerPoint, this bottom formula here, plug all the parts in, we get an estimate of convexity, an approximation of convexity of 27.47149. If we calculate it exactly, we get 27.471439. So again, super close. And so for all intents and purposes, we can use that shorthand calculation from the PowerPoint and get very close to calculating duration, or coming up with duration and convexity. Probably have you do this on an exam. This is very easy, very straightforward in terms of applying the calculations, and so be ready to do those on any quizzes or exams. Let's keep moving here and go to the next slide and look at convexity in the bond market. Whenever we're looking at 2 different bonds with equal durations and the same yields, and this is a picture of it here on the right, bond B has higher convexity than bond A. So if we kind of consider this scenario with equal durations and the same yields, we really should be more inclined to buy bond B, because it's going to have a higher price than bond A at every possible yield to maturity except the current one. So if there's any change in yields, any change in interest rates, bond B is going to have a higher price than bond A in response to that change. So we would be leaning towards bond B in this situation. So the value of convexity is dependent on the expectations for future volatility of interest rates. If we think there's going to be a lot of volatility in interest rates, we would want bonds with a higher convexity, because they're going to respond better to those big changes in interest rates. So that's the portfolio consideration for convexity. And lastly, let's just look at a few properties of convexity and we'll be done with this material. The first property, as the yield increases, as the yield of maturity increases, the convexity of a bond will decrease. And I'll let you kind of look at some of the calculations and see how that would be the case. For property 2, for a given yield and a maturity, the lower the coupon, the larger the convexity, the larger the change in price in response to interest rates. And that's very much like the duration property. And the last one here, for a given yield and modified duration, the lower the coupon, the smaller the convexity. So now we're holding yield and modified duration constant. So if we've got a lower coupon, the convexity will be smaller. So each of these are in the text. Take a look at that and you can have more discussion of it. And so we'll finish here with the bond price volatility material. And I'll see you in the next set of videos next time.